Okay, so good morning, everyone. Today we are going to do the topic of chemical bonding, which is from inorganic chemistry. So it is quite a very interesting and easy topic. So we'll talk about what is chemical bonding. We know that any bonding between two chemicals is known as chemical bonding. So between carbon and carbon, between carbon and hydrogen, between carbon and oxygen, carbon and nitrogen, oxygen and oxygen, sulfur and sulfur, these all are chemical. So, a chemical bond is lasting attraction between atoms, ions, and molecules that enables the formation of chemical compounds. Okay. So, how chemical compounds are formed? Chemical compounds are formed by the chemical bonding. The various types of chemical bonds are ionic bond, covalent bond, hydrogen bond, and metallic bond. These bonds between two atoms depends on the electronegativity difference between the atoms. Okay. These bonds depends between the electronegativity difference. Okay. Between any atom. So if there is any electronegativity difference, then there will be the bond between these atoms. Okay, they can be formed by the sharing of electrons, which is covalent bond, or gain or loss of electrons is known as ionic bond. Okay, hydrogen bond is there, which is formed by the electronegativity difference, and hydrogen is less electronegative, so very much electronegative atoms forms hydrogen bond. Okay, now and vice versa is also right. If the electronegative difference between the atoms is there, then they will form these types of bonds. And if the chemical bonding between the constituent is weak, the compound form would lack stability and thus easily undergo another reaction to be more stable chemical compound. Okay, so like this, the stronger bonds are formed if they have a very much difference in the electronegativity, and if less difference is there in the electronegativity, then they will lack the stability and they will form their own compounds by reacting with some other constituents. Okay. To find the stability, the atom try to lose their energy. Okay. So minimal energy is no stability. Okay. So matter interacts with other matter to form matter interacts with other matter to form a compound. Okay. So force is exerted by one force is exerted, okay, on one by other. When the forces are attractive in nature, okay, so the energy decreases, and forces are repulsive in nature, then the energy increases. Okay, so the attractive force that binds two atoms together is known as chemical bond. When the energy is decreasing and the atom is going into the stable, the compound which is formed is going into stable state. Okay, then it is called as the chemical bond which is formed. Because attractive forces, we know that the energy decreases. Now, various theories for chemical bond. First is Albert Albert Kossel and Gilbert Lewis first explained, okay, that chemical bond formed due to the inertness of noble gases, okay, in the year 1960. Noble gases, we know that whose electronic configuration is like, if I take the example of neon, krypton, argon, okay, neon, krypton, argon, helium, okay. So if I take the example of helium, then its outermost octet will have the total 8 valence electron, which will fulfill its 8 electron rule. Okay. And thus it is very stable. Okay. So Albert Kossel and Gilbert Lewis firstly explained the establishment of chemical bonds, successfully explained in 1916 due to the inertness of noble gases. Okay. Then Lewis' theory of chemical bond. An atom can be viewed as a positively charged kernel. Okay. So if I am having an atom, it can be viewed as a positively charged kernel, the nucleus plus the inner electrons. Inner electrons, the whole atom is known as the kernel and the outer shell. The outer shell can accommodate a maximum of 8 electrons only. Okay. Outer shell can accommodate means like if I am having the outermost shell, so there can be only 8 electrons which can be filled. Okay. In case of any noble gas, if I take the example of neon like this, okay, the 8 electrons present in the outer shell occupy the corners of the cube which are okay, so they surround corner of the cube. Okay, these are the 8 electrons which are surrounded. Okay, now atoms can achieve their stable state configuration by forming chemical bonds with other atoms. These chemical bonds can be formed either by gaining or losing of electrons. Okay, so I just told you that ionic bonds is formed by the gain or loss of electrons. Like in NaCl, if we talk about NaCl, Na positive and Cl negative will be formed because Na is known as to have the atomic number of electrons. So it will have a 281, and chlorine is known to have the atomic number of 17, so 28, 7. So it requires one electron, it donates one electron. That is why it is losing and this is gaining. So this gain and loss of electron is thus making the covalent bond between NaCl. So if Na positive is losing, it will get a positive charge. Cl minus is taking the, so it will get a negative charge, and thus Na positive and Cl negative is the sodium chloride. Magnesium chloride, as we see, Mg2 positive, magnesium is having atomic weight of 12, 2, 8, 2. 2 is, it will lose. Cl2 molecules are there, 287. It will require 1 for the here, and 287 it will require 1. Total 2 are required. So it will give 2 electrons and it will receive 2 electrons. Okay. Like this, plus Cl minus 2 will be formed, which will give you MgCl. Okay. Because plus 2 and minus 2 will cancel and it will become MgCl. MgCl2. Why Cl2? Because Cl is having a minus 1 charge, and if we require Mg is having a plus 2 charge, Cl is having a minus 1 charge. So Mg plus 2 is being neutralized by 2 Cl negative, 2 Cl ions, so it will give you minus 2 charge. Okay, if you will apply Cl2 over here, then it will become minus 2. Okay, Cl2 over here, then it will become minus 2. Okay. So the atom having octet configuration 8, we know that NaCl and are forming the ionic bond cases due to sharing of their electrons. Okay, they are sharing their electrons. So in case of MgCl2, it will be Mg plus 2 and Cl2 minus 2. Okay, so it will give you MgCl2. Now only the electrons present in the outer shell are known to as valence electrons. Okay, in the outermost shell electrons. Okay, valency is the number of electrons which are present in the outermost shell, which are taking part in the formation of chemical bonds. Okay, and Gilbert Lewis used specific notation metaphor known as Lewis symbol. Okay, to represent these valence electrons. Generally, the valence electrons of an element is equals to the number of dots in the corresponding Lewis system, or 8 minus the number of dots. Okay, 8 are the valence electrons which should be there in the outermost octet. And Lewis symbols for lithium is 1, nitrogen is 5, and argon is 5 are given. So, like if I'm taking lithium, lithium is having a atomic number of 3, 2, 1. Outermost will have 1. Nitrogen we know as 7, atomic number. It will be 2, 5. So nitrogen will have 1, 2, 3, 4, and 5 valence electrons. Argon is a noble gas. It always had 8 electrons in its outermost octet. Its atomic number is 18. So this will give you 2, 8, 8 valence electrons. Okay. And this is the atomic number of argon gas. Now here the number of electrons or the dots that are encircling respective symbol represent the number of valence electrons in each atom. These are the valence electrons. Okay. Now, Cauchy's theory of chemical bonding. Just now we were on the Lewis theory, and now comes to the Cauchy's theory. So these were the theories. Okay, this was combinedly given by Cauchy and Gilbert Lewis, and Lewis telling that the valence electrons are A, and they are encircling, and stable state configuration is attained by the outermost shell. Now, Cauchy's theory of chemical bonding. Noble gases discrete the very electronegative halogens and the extreme electropositive alkali metals. Okay, they just form bonds with them. Halogen can form negatively charged ion by gaining of electron. Alkali metals can form positive charged ion by loss of electron. Okay, so it's not just about the noble gases. What Cauchy is telling that halogens and alkali metals can easily form. Okay, these negatively charged ions and positively charged ions have a noble gas configuration that is 8 because NaCl, if we take the example, now Na positive, Cl negative, what they will give to 8, comma 1 is for 11, which is the atomic number of sodium, whereas in chlorine it is 17, so it will give you 2, 8, comma 7. So the outermost valency is 8 over here. So it is fulfilling that rule which was given by Lewis of the noble gases. Okay. The general configuration of noble gases except helium is NS226. NS226 means like if you take about argon, 2s2, 2p6. Okay, this is what the general configuration. As unlike charges attract each other, and these unlike charged particles are held together by a strong force of electrostatic attraction existing between them. For example, MgCl2, the magnesium ion, the chloride ion are held together by a force of electrostatic attraction. Okay, they are held together by a force of electrostatic attraction. This kind of chemical bonding exists between two unlike charged particles is known as electrovalent. Okay, two unlike charged particles like Mg was having +2, Cl was having -1. So these were two unlike charged particles, and this bonding is known as electrovalent bond. Okay, what this is called as? This is called as electrovalent bond. Now, explanation of Cauchy's and Lewis approach. In 1916, Cauchy and Lewis succeeded in giving a successful explanation based upon the concept of electronic configuration of noble gases about why atoms combine to form molecules. Atoms of noble gases have little or no tendency to combine with each other. Okay. So if I am telling that noble gases are inert, because they have fully filled orbitals octet of 8 electrons. Okay. So they don't have the tendency to combine with each other or with atoms of other elements. This means that these atoms do not have the any bonding. Okay, they are having their stable state configuration. Okay, and due to the stable state configuration, the noble gas atoms either have any tendency to gain or means they don't have any tendency to gain or lose electrons, and therefore their combining capacity or valency is 0. Okay, and therefore so they are so inert that they even do not form diatomic molecules and exist as a monoatomic gases. Okay, so if I tell that hydrogen exists as a diatomic molecule, nitrogen, oxygen, chlorine. Okay, but neon, argon, krypton, helium, they all are inert gas and they are monoatomic in nature. Okay, then Pajan's rule. What is Pajan's rule? It is another rule, theory which has been there. So first of all, Cauchy's and Lewis were there, and now Pajan rule predicts whether a chemical bond will be a covalent or an ionic bond. Okay, covalent or ionic bond. A few ionic bonds have partial covalent characteristics, which were first discussed by Kazimierz Pazans in 1983. At that time, with the help of X-ray crystallography, he was able to predict ionic or covalent bonding with the attributes like ionic and atomic radius. Okay, so how I am going to identify between the bond which are formed by the gain or loss of electrons or bond which are formed by the sharing. So we can classify certain compounds as ionic and other compounds as covalent. Now, if we were to ask among the alkali chlorides, which is most ionic, okay. To answer these kinds of questions, we apply Fajran's rule. Okay. So rule has three factors. First, size of the ion. Smaller the size of cation, the larger the size of the anion, greater is the covalent characteristic. Okay. If the cation size is less, anion size is more, then covalent character will increase. The charge of cation, greater the charge of, this is for the size. Now we will talk about the charge. If the charge on the cation is greater, then ionic bond or character will increase. Okay, because ionic character is for the gain or sharing of electrons. Okay, so if the charge on cation is more, then the covalent character will be more. Okay, so of the ionic bond, covalent character will be more. Ionic bond will be formed if any positive, if any charge is there, then ionic bond will be formed. But the covalent character will be more if the cation is having more positive charge. Now, electronic configuration for cations with the same charge and size. The one with n minus 1, Dn, and ns0, which is found in the transition elements, have greater covalent character than the cation with ns2 np6 configuration. Okay, if the cation is having n minus 1 d, it is filled in the d orbital, it is filled in the n or s orbital, so which is commonly found in the alkali or alkaline earth metals. Okay, this electronic configuration found in transition elements. Okay, and this is found in alkali and alkaline elements. Okay, this comes in first period because alkali metals are sodium. Okay, like this, magnesium. Then this rule one is the about the polarizing power. Okay, explanation of these Fazan's rules, the rules which we have studied over here: size of the ion, the charge of the cation, and the electronic configuration. So what they assume over here. So the first rule speaks about the polarizing power of the cation. How much cation can polarize? Okay. If the cation is smaller, then we can say that the volume of the ion is less. And if the volume of the ion is less, then we can conclude that the charge density of the ion would be high. Okay. Like if in a small space, you have to keep some atoms. So density, which is equals to mass upon volume. So the mass will increase, then the density will also increase. And volume, if it is decreasing. Okay, so here we are having less volume. Volume was less, that is why the density was increasing, because density is inversely proportional to volume. If volume is decreasing, then the density will increase. So here the volume of the ion is decreasing because the cation size is smaller. Then the charge or the ion, the volume will be very less. And if the volume is less, then the charge density will be very high. Okay, charge density will be very high. Since the charge density is high, the polarizing power of the ion would be high. This makes the compound to be more covalent. Covalent character is more polarizing power. If carbon is making bond with the carbon by the sharing of electrons, then the polarizing power has to be high. Then rule 2, second rule speaks about the polarizability of an ion. Larger the ion, less is the effective nuclear charge that holds the valence electrons of ion in place. Okay. If my ion is large, then the effective charge will be very less. Okay, the nucleus will have the effective charge to bind the outermost electrons. Okay, but over here, what will happen? If the size will increase, then this effective Z effective or the nucleus effective charge will decrease. Okay, and thus the polarizability power will decrease. Okay, since the last electron is loosely bound in larger anions, it can easily be polarized by cation, therefore making the compound more covalent. Okay, thus it is making the compound more covalent because it can easily be polarized. So, since the last electron is very loosely bound because the nucleus does not have that Z effective charge, okay, so it can easily be polarized by a cation. It can easily be polarized by a cation, means cation can easily remove that and therefore making the compound more covalent. Then rule third, it shows about the, it's a special case. If we want to find the more covalent compound among mercury chloride and calcium chloride, we cannot use size as a factor, okay, because they both have the same size. This is because both mercury and calcium have the equal size. Okay. This to explain this third rule is there. The electronic configuration of mercury is 6s0 5d10. That d orbital 10 electrons are there. We know that d has 5 orbitals, where p has 3 orbitals, px, dy, and pz, dxy, dyz, dx square, dxz, and dz square. These are the 5 orbitals of d. Here in the p orbital, if we see 6 electrons can be filled. Here in d orbital, 10 electrons can be filled. This configuration is called a pseudo-octet because d orbital is fully filled, but the element does not have 8 electrons or an octet. Okay, because d orbital is completely filled, so it has the stable state configuration. Okay, and we know that the d orbitals are not good at shielding. Okay, they are not good at shielding. Shielding power is that if my Z effective nuclear charge is there, so it is shielded by the negatively charged electrons. Okay, so this protection is not there. Okay, so it can be easily polarized. Okay, this shielding power is the Z effective the nucleus so that it can shield the whole atom or the nucleus so that the negatively charged electrons does not go away. But the orbitals are not good at shielding, so we can say that the chlorine anion will be more polarized because of the orbital is poor at making shielding, and thus mercury chloride will form a more covalent bond than the calcium chloride. Okay, we know that calcium and mercury have comparatively small similar size, but mercury has fully filled a d orbital, and d orbital is not good at polarization. And if the polarization is not good, then the uh, like if polarization is not good, then they can be easily available for making the covalent bonding. Okay, then the Z effective decreases and they can be easily polarizing power will increase. If the shielding increases, then the polarizing power will also increase. Okay, polarizing power will increase means they will be easily available to form covalent bond because the Z effective decreases because the nucleus is now not attractively binding those electrons and they are easily available. Cl negative ion is easily available to form the bonds with the mercury. So mercury will form a covalent bond, then CaCl2 because calcium is having a very good Z effect. So it will not allow the chlorine ion to form the more polarized and form the covalent bond. Okay. That is why CaCl2 because calcium, now what the reason for the calcium chloride? So as to attain a stable state configuration, it is having the outermost electron as the octet rule, having 8 valence electron and thus attaining a noble gas configuration in CaCl2. Okay, so amongst the alkali chloride, which is more covalent, so we will answer that mercury chloride is more covalent due to the more polarizability and d orbitals have the very less shielding effect. Okay, so the anion will become more polarized. Okay, since the anion is the same, we have to compare the cations according to Fajan rules. Okay, so what is Fajan rule? If the anion are same, Then now we have to compare the how much cations are there. Okay. So smaller the cation, more is the covalent character. Okay. If the cation is small, then more is the covalent character. LiCl is more covalent because smaller the cation, it is just having a plus one positive charge in Li. If it can go like lithium, if I talk about, it is having a 3 as the atomic number, 2, 1 is its electronic configuration, 1 is the outermost electron, so valence shell electron will be 1. If it is going to donate, it is getting lithium positive charge and it is have a stable state configuration. So it is the most stable covalent, it will form the most stable covalent bond because it is the smaller the cation. What they are telling, smaller the जितना ज्यादा हमारा कैटायन छोटा होगा उतना ही अच्छा वैलेंस, उतना ही अच्छा कोवलेंट बॉन्डिंग बनेगी. Okay, then consider aluminum iodide. Aluminum iodide is Al(I3). I3 is I3 negative ion and Al plus 3 positive ion because aluminium is having a valency of 3. This is an ionic bond which was formed by the transfer of electrons. Al was having a plus 3, iodine was having a deficiency, so it donated, so it is having a positive charge, it received, so it was having a negative charge. The iodine being bigger has a lesser effective nuclear charge, thus the bonding electrons are attracted lesser towards the iodine nucleus. Okay. Similar thing was there, the polarizing power was there, the concept is same because the iodine is having a very big size. If we talk about iodine molecule, Z effective, like the positive charge in the center. So the positive charge in the center will be less polarizing power for the negative charge. And thus bonding electrons are attracted lesser towards the iodine nucleus. Okay, so bonding electrons, if we talk about, are attracted lesser towards the iodine nucleus because the nucleus is having a shielding effect, is having a less shielding effect, and thus the Z effective decrease. On the contrary, okay, iodine was having a bigger size, but aluminium having 3 positive charges attracts the shear pair of electrons towards itself. Okay, this leads to insufficient charge separation for it to be ionic and thus it results in the development of covalent character. Okay, because iodine was having a Z effective very less because it was having a very big size, but aluminum is having a small size but having 3 positive charges, okay, which are attracted by the shared pair of electron by the I3 negative. Okay, so what is happening over here? This is how the Al(I3) is being formed. Okay, and thus the development of covalent character is there in Al(I3). Now, if I take the example of AlF3, the ionic bond, which is also formed by the transfer of electron, but the fluorine here is smaller, attracts the shared pair of electrons more towards itself, and thus there is sufficient charge separation to make it ionic. Now, fluorine is having a small size because we know now fluorine, bromine, and iodine. Iodine was in terms of size we are taking. It is largest size in halogen, and fluorine is having small size. Okay, so due to small size, Z effective increases. Okay, it is the nuclear charge. Okay, and thus ionic bond is formed in fluorine because it's smaller and Z effective increases. It is not allowing the formation of the shield, de-shielding of the electrons, and the polarizing power is increasing. Thus, the ionic form is formed. Okay, polarizing power is decreasing over here because it is not allowing its electrons to form bond with others. Okay, so only by the gain or loss of electrons it can form the bond. That is why it's ionic due to the charge separation. Now, which compound should be theoretically the most ionic, the most covalent amongst the metal elements? Okay. So the smallest metal ion and the largest metal ion should technically move more covalent. Okay. Lithium is more covalent, lithium iodide, because covalent character is directly proportional to the cation charge should be small. And lithium is just having a +1 charge and it can easily donate so as to attain a stable state. If it is donating this one, then it will have a 2, which is the stable state. Electronic configuration. The largest cation and the smallest anion should be most ionic. Okay. Largest cation and the smallest anion should be more ionic. For example, cesium fluoride should be most ionic. Okay. Lithium iodide should be most covalent because covalent character is directly proportional to decrease in the cationic charge. And largest cation and smallest anion. This was for the covalent character, smallest cation is required, but largest cation is required for ionic character. So largest cation and smallest anion will be having the most ionic.